this is one reason I don't believe there's a wave function of the universe. It doesn't make any sense. The universe as a cosmologist, it's what is it? It's the large-scale properties of what we see around us. So we look at that universe from the outside, right? We have a telescope, and with the telescope we count galaxies. So the telescope and us is the observer. The galaxies counted is the system we're observing. So it's fine. It's perfectly fine. We can see this galaxy. We see how much they're moving apart from us. We can trace back how compressed they were before. We have a system. We can model it. And we're observing these degrees of freedom from the outside, in the sense that we're not part of those degrees of freedom. We are spatially inside, but we're observing it from not being one of them. It's like if I'm in this room and I study the air of this room. I can be inside the room, but I'm not the air. Okay. So that's fine. On the other hand, the idea of describing the totality of thing, of ascribing a wave function, for instance, to the totality of thing, which is common, I don't think is a good idea, because let me be more specific. The wave function of an object, the wave function of this pen, it's a way of computing where this pen is going to show up with respect to me next.
Mm-hmm, mm-hmm. Right.
So when I'm in a laboratory and do some quantum measurement, and I use a wave function, the quantum state, for predicting what I'm going to see, I'm deducing this wave function from what I saw. Okay, I've seen this pen, the spin of this particle in one way goes to some apparatus, and I have the probability of the spin being this way or that way after the pen goes to apparatus. That's a typical super simplified calculation. And to do this calculation, I use the quantum wave function of this pen. But what is this quantum wave function? Is what I know about the pen, and is a description of what should I expect of the pen. So it's something that regards the pen and me. It's a relative state. And the person who first has understood that when you use quantum states in quantum mechanics, we always talk about relative state, is Everett, in several decades ago. Everett has understood that states are relative states. So the quantum state of an object is always relative to another object. Okay, this is a state is a relational thing. And once you understand that, clearly, the totality of things does not have a quantum state. Because unless you believe there's God, then God do quantum experiments on the. But then God is not part of the universe. You have then. The universe and God together don't have a quantum state, right? So the wave function of everything, of the universe in the sense of everything, I think is not something that should enter in. Is not a useful notion in physics. The wave functions are relational notions that connect a system with another system considered observer.
If you enjoyed that clip, then the full podcast is out right now. You can click around here, as well as subscribe to get notified. Enjoy. Brand new full-length podcasts every Tuesday at 2 p.m. on Theories of Everything.